not more than one material is that there is a single material but the principal axes are not by inspection. Or actually, no, let's put it this way. There is no axis of symmetry, it's better to say. Okay? In this case, you have to, now the text does not force you in any of the homeworks to actually compute the principal axis. It gives you already what the principal axes are, even though the section may be rotated. But we will go beyond that. For example, the problem may be like this, the centroid is here, and the principal axis may be tilted like this. Okay? Now in the book, they may tell you that this angle is 15 degrees. We can have problems, and we will have problems, in which you have to determine what the angle is. Okay? Not just simply take it as a given. Now once the principal axes are given, or are computed, this type of problem requires knowing what is that angle, and then how to calculate the stresses. And the stresses at any point, as I just explained before, is a question of superposition. The effect of the moment that is acting on x prime plus the effect of the moment that is acting along y prime. Okay? In order to be able to do these problems, you need to know what is Ix prime and what is Iy prime, but we have formulas in terms of Ix, Iy, and Ixy. So the one item that you have no, no prior computational practice or experience is on the calculation of Ixy. So on the next section, I will do an example in which we will calculate Ixy and apply to a problem of this nature. Okay? And I think at that point, I'm not 100% sure, but I think at that point this might be material which is sufficient to carry you for this next week while I'm away, plus the homeworks, plus the recitations, and then we'll catch the subject matter in the next section, which is the shear center, when I return and we meet the Monday of the other week. Now, let's see. Okay, so let's just stop there, and I'll prepare something for the example.